We can make React Memo work for prop values that are objects as well. We just need to tweak the way we create and store those objects a little bit. There is an extra hook provided by React that helps us with that, and that is the use callback hook. Use callback is a hook that allows us to basically store a function across component executions. So it allows us to tell React that we want to save a function and that this function should not be recreated with every execution. With that, one and the same function object is stored, so one and the same place in memory, and therefore the comparison does work. Because, just to make this clear again as well, if you have object 1 like this and you have object 2 like this, which look similar, you learned that they aren't similar in JavaScript. If you, however, set object 2 equal to object 1, you point at the exact same place in memory, and therefore now object 1 will be equal to object 2. And that's in the end what use callback does for us. It will save a function of our choice, basically somewhere in React's internal storage, and will always reuse that same function object then when this component function executes. And using it is simple. We just wrap the function we want to save with it. So here we use the use callback hook and pass our function as a first argument to use callback. And use callback then returns that stored function, and when the app function reruns, use callback will look for that stored function, which React stores for us, and reuse that same function object. So if we know that this function should never change, we can use callback to store it. Now you see I got some yellow squiggly lines here though, which tells me that I did probably forget to pass an array of dependencies. Use callback, like use effect, actually wants a second argument. And it wants it even more so than use effect. And just like for use effect, the second argument should be an array of dependencies of this use callback call. And the dependencies here are the same as they are for use effect. Anything you use in your function, which is coming from the surrounding component, so any state or props or context, should be specified here. Now here we only have the state updating function, and we could add this as a dependency, but we don't have to, because as mentioned earlier in the course, React guarantees us, actually with help of use callback probably, that this will never change, so that this will always be the same function object. Hence, this is an exception which we don't have to add. And then in this simple callback, we have nothing else. Keep in mind that this code here is just a function we pass to setShowParagraph. So that is totally contained inside of our callback function. So therefore here we have an empty array of dependencies, which basically tells React that this callback function, this function here, which we want to store in toggle paragraph handler ultimately, will never change, that it has no dependencies, and that therefore always the same function object should be reused when the app component re-renders. Hence now if I save that and I reload, we see button running once, but then you never see it again. Because now React Memo is able to do its job because we ensure that all the prop values we pass in are comparable. In this case, because this toggle paragraph handler function object is guaranteed to always be the exact same object in memory because of use callback. Let me come back to use callback because it is important to understand this. Use callback allows you to save a function so that you can reuse it. Now you had to specify this strange dependency array. And I don't know about you, but initially you might think, what do I need this for? My function has always the same logic across re-render cycles. Well, keep in mind that in JavaScript, functions are closures, which means they close over the values that are available in their environment. Now again, if you're not 100% sure about closures, attached you find some resources that get you started with them, because you need to know closures to fully grasp how React works. Let me give you a concrete example. Let's say we have a second button which enables the toggling functionality. So a button that makes the other button work. Allow toggling. For that we need a new state. Allow toggle and set allow toggle, and initially that's false. And we have a new function here. Allow toggle handler. We could again use callback, but for the moment let's omit it. Doesn't matter here. Here I want to call set allow toggle and set it to true. So I always set it to true here. This does not toggle the toggle value, it just enables toggling for the other button. Because now, and that's the gotcha, I will not only bind the allow toggle handler here to the new button. Instead, I will use the allow toggle state snapshot in my other function here to check whether I'm allowed to set show paragraph. So now here I will check if allow toggle is true, and only if it is, set show paragraph will be called. So the show paragraph state will only be updated if toggling is allowed. And now I will also reuse show paragraph here to replace my hard-coded false value. With that, if the app reloads, you will see that if I click the toggle paragraph button, nothing happens. Now if I click allow toggling, now the other button should do something, and when we click it, we also should see app running. However, if I click it, still nothing happens. And that's because functions are closures in JavaScript and because we're not using useCallback correctly right now. We even got some yellow squiggly lines here to make us aware of that problem. At least I got them here. Now what is the problem though? Functions in JavaScript are closures. That means when a function is defined, which happens when the app function runs in this function's case, when that function here is defined, JavaScript basically locks in all the variables that we're using in there. All the variables that are defined outside of the function that we are using, I should say. In this case, the allow toggle variable. That is a variable or a constant coming from the app function, and I'm using it inside of this function. Therefore, JavaScript closes over that constant and basically stores that constant for that function definition. That means the next time this function here, the toggle paragraph handler, is executed, this stored variable will be used. And with that, the value of that variable at the point of time it was stored. This generally is perfect because this allows us to use variables from outside the function in the function and call that function at any point of time we want, which is exactly what we want for a function that we bind to a button. The problem with that and with useCallback, however, is that with useCallback, we're telling React to store that function and exactly that function somewhere in memory. Now, when the app function is re-evaluated and re-executed because the toggle state changed, then React will not recreate this function because we're using useCallback where we told React that we don't want to recreate it under all circumstances. So therefore, the allow toggle value React stored for our function is still the old allow toggle value from the first time the app component was executed, not the most recent one. Because JavaScript, as I just explained, stored allow toggle, this constant, when it created that function here. And that's of course a gotcha here, that's a problem. There are cases where we actually want to recreate a function because values being used in that function that are coming from outside the function might have changed. And here we have such a case. So here we would want to add allow toggle as a dependency in our dependency array. And that tells React that we generally want to store that function. But whenever allow toggle changes and it has a new value, we want to recreate that function and store that new recreated function. And this ensures that we always use the latest allow toggle value inside of that stored function. If allow toggle does not change, however, then we don't recreate the function. And with that, if I save this, if we go back, now if I click toggle paragraph, nothing happens initially. However, if I now click on allow toggling, now we'll see that if I now click toggle paragraph, we do get our paragraph and all the expected output. It's also worth noting, of course, that for toggle paragraph, we see button running, but we only see it once. And that's actually our second button where React Memo has no effect because we're not using use callback on the allow toggle handler. We would see it twice if the button for toggle paragraph would also be re-rendered. But that's not the case because our use callback call here ensures that we're not rebuilding this function every time. We only did that once when allow toggle changed. Now I know these are concepts that can be confusing. In the end, it's not so much React though, it's more JavaScript, and you have to understand how closures work, and you have to understand that primitive reference value concept. If both is clear, it's absolutely clear how React works. And I hope that this and the last lectures could help you understand that and made it clear how use callback works, how functions are re-executed, and how React Memo works and how that works together with use callback. So now, before we proceed, let me sum up what we just learned so that this is all really clear because it is important. In React apps, you work with components, typically with function components in modern React. Those components have one job in the end, and that is this JSX code which they return. This tells React what the output of that component should be. Now in your React components, you can work with state or with props or with context, though props and context, as I mentioned, all come down to state changes in the end, to make changes to a component and to make changes to the data that affects this component or that affects parts of your application. Whenever you change state in a component, that component where the state changed is re-evaluated, and that simply means that the component function is executed again. So all this code runs again, and therefore we get a new output. This might actually be exactly the same output as before, but it could also look different. For example, if suddenly a paragraph is rendered or not, or as in the case of the demo output component, if the text is rendered or not. React simply takes the result of this latest evaluation and compares it to the previous evaluation's result. And it does that for all affected components. And then it hands off any changes, any differences it identified to, in our case, React DOM, because we are using React DOM to render our React app here in the index.js file. And React DOM will take those changes and apply them to the real DOM in the browser. And really only those changes, nothing else. Now, when React re-evaluates a component, it does not just re-evaluate that component, but since it reruns the entire function and therefore also rebuilds this JSX code, rebuilds the output for this latest snapshot, so to say, it will also rerun all components that you have in this JSX code. Like in this case, it will rerun the demo output and the button components. Now, to avoid unnecessary re-executions of child components, you can use React Memo to tell React, hey, please only execute this component function again if the props really changed. So if we got real new values in there. If we got no new values, please don't re-execute this function. Now, since re-evaluating a component means that the entire component function runs again, that can have strange effects if you're not aware of the fact that this really means that everything in this function runs again. And therefore, if you, for example, create functions in the function and you pass those functions through props to other components, you will indeed get a new function object, and even React Memo will then not be able to help you because objects are reference values, and comparing them with equal signs, which is what React Memo does under the hood, will not work. For primitive values, you will therefore not have that problem. That's where use callback comes in and can help you, because with use callback you can tell React that it should store a function and not recreate it when the surrounding function runs again, as long as certain dependencies didn't change. That is what we learned thus far. Now, there are a couple of open questions though. For example, if the app function runs again whenever the state changes, doesn't this mean that we all the time reinitialize our state? Because we also execute use state over and over again then. Why is this not causing problems? Well, it's questions like this and general state-related questions that we're going to dive in next. Obviously, state is a crucial concept in React. Ultimately, everything comes down to state when it comes to re-rendering components and changing what's on the screen. So therefore, components and their interaction with state, that is really a core aspect of React. And it is worth noting that both, of course, is managed by React. This components concept comes from the React library, and React also takes care of your state that is attached to components. It takes care, for example, by using the use state hook, and that's how this interaction between components and state is handled. Speaking of that, one of the most common forms of managing state is to use the use state hook. With that, you create a new piece of state, you could say, and you automatically attach it to a component, the component in which you call use state. This attachment, kind of, is done behind the scenes by React. Because when you call use state, React behind the scenes creates a new state variable, you could say, which React manages for you and which React also for you ties to this component. Now, I mentioned at the end of last lecture that it's strange that even though we call use state every time the app function runs again, we don't seem to lose or reinitialize our state all the time. The reason for that is simple. Use state is coming from React. And I just said that React is managing the state and the connection to the component for you. And as part of that management process, React makes sure that use state and the value you pass as a default value to use state essentially is only considered once. The first time ever a component is rendered, so the very first time the app component runs, use state, when executed, creates a new state variable which is handed off to React and which is managed by React. React then basically memorizes to which component that belongs, the app component in our case. And it uses the default value to initialize the state with that value. For subsequent app function calls, so for re-evaluations of the app component, when use state is being called, no new state is being created. Instead, React recognizes that it already has a state for this component, and it instead simply updates that state as needed, because the app function re-ran because some state changed most likely, and therefore React will only do that state management and updating. It will never reinitialize the state unless the component was totally removed from the DOM in the meantime, which in case of the app component will never happen since it's our root component. For child components, if it's rendered conditionally, for example, a component might be removed, and in that case, if it's then later reattached, a new state would be initialized. But as long as a component stays attached to the DOM, state is only updated after that first initialization. Now, that's one important note to take, and of course the same is true for use reducer, for example. Now that's not all you need to know about state though.